Okay, so we want to find all the absolute extrema from A to B, or in this case from -2 up to +3. So your first step is to make a chart, an f of x or an xy chart, in which you try to figure out the values of the endpoints. So we're trying to figure out where are we starting, the left endpoint, and where are we stopping, the right endpoint, because that might end up being my lowest and or highest point. So I'm going to take -2, and I'm going to plug it here into f. And then I'm going to work that out, see what that ends up being, and I end up getting -4 when I work that out. Then I'm going to do the same thing with 3. I'm going to take 3, I'm going to plug it in, and then I'm going to work that out. So after I work that out, I get, when x is 3, that y is -9. So what have I found? I've found that this is where I start at -2, -4, and this is where I stop at 3, -9. And that would be the very first thing you do for an absolute extrema question. So we found our left endpoint and we found our right endpoint. So the next step, step 2, is to take f and derive it. So I'm going to go ahead and derive f right now using the add-subtract rule. And for each term, I'm going to be using the power rule. And then I want to set the derivative equal to 0, and then I want to try to solve this equation. So to solve this equation, I need to factor. I'll first take out a 6. That should make it easier. And then I'll work with this trinomial. And I get x minus 2, x plus 1. I'll drop the 6. This gives me 2 solutions. One of the solutions is -1. And the other solution is +2. So before I go on, let me explain why I came up with this part. So when your derivative equals 0, the reason I set it equal to 0, that means that you have a horizontal tangent line. And if you have a horizontal tangent line, it means that you might have a relative extrema. So what I've done now is I've found 2 x's that might be relative extrema. And relative extrema might then turn into absolute extrema. And so that's why I set the derivative equal to 0. So I'm going to take my 2 potential relative extrema. They're also called critical points. And I'm going to put them into my xy chart. So now we're going to take the 2 potential relative extrema, and we're going to go back to the original function and plug it in. So I'm going to figure out what f of -1 is. So after you work it out and you evaluate that, f of -1 ends up being 7. And then I'm going to repeat the same process with the 2. I plug in a +2, I work all that out, and I end up with y being -20. Now what I want to do is I want to pay close attention to the y values and figure out which one of these is the lowest and which one of these is the highest. So if you take a look at all your y values, the lowest y value occurs here. And if you look at all your y values, the highest one occurs here. The lowest one is called your absolute min, your absolute minimum, and the highest y value is called your absolute maximum value. So we have our answer. We know we've located the absolute minimum and the absolute maximum value. But I wanted to explain to you how this all works. So what we have here is f of x, the cubic function, and it's been drawn here on the calculator from -2 up to +3. So what you first figured out was the left endpoint right there, -2, -4. And the x's are scaled by 1 and the y's are scaled by 5. So there's -2, -4 right there, the left endpoint. Then you figured out the right endpoint, which was 3, -9. And then you figured out the relative max, which is here, -1, 7. And you figured out the relative minimum, which is here, 2, -20. And that's why the relative maximum ended up being the highest point in the interval, and the relative minimum ended up being the lowest point in the interval, and that's why it changed its name from relative min to absolute min. And here, relative max became absolute max. And in this particular case, neither of the endpoints were the lowest, nor were they the highest in the closed interval.